Hello everyone, this is Vrishali, and in my last sessions we learn about the binary classification and multi-class classification technique, and also we learn about the introduction, supervised, unsupervised learning, reinforcement learning. I have mentioned the link of that videos in below description box. Now in this session we will learn about the next topic in classification unit, that is support vector machine, which is also called as SVM. So let's see. Okay, so first we will understand about what exactly support vector machine. So support vector machine or SVM is one of the most popular supervised learning algorithm. And support vector machine, this algorithm generally used in classification as well as regression problem. But generally this algorithm used in classification problem because it generate more accurate result, or more accurately they classify the data. That's why SVM algorithm used in classification. So the goal of SVM algorithm is to create a baseline, or to create a proper decision boundary in between the particular classes. See in this below diagram, there are two classes. One is class A and another one is class B, right? So these two classes are properly classified, and this middle line is called as decision boundary. And this decision boundary generated by the SVM algorithm. So SVM algorithm properly classify the data. And SVM algorithm generally used for face detection, image classification, text categorization in this field. Next. So next point is key concepts of SVM, or we can say that these are the some components of SVM. The first one is support vector, hyperplane and margin. Now see in this particular diagram, okay? So there are two classes. One is green class and another one is blue class, right? So this the particular dotted line is called as hyperplane. Okay. So we can say that hyperplane is a decision plane or space. Okay. Or they can divide the particular class in particular set of objects. See here, the dotted line present in blue class. So this is a one hyperplane, right? Because from this point they classify the another class, right? And next hyperplane is into the green class, because this is a particular green dot is a first dot, right? Is near to decision boundary. So this is a one hyperplane. So hyperplane is classify the data in particular set of objects. So actually binary classification having positive and negative class, right? So that's why there is a one is positive hyperplane and another one is negative hyperplane. So this is a concept of hyperplane. They classify the data from this particular data set. Okay, this is a blue point is there and this is a green point is there, right? So from this point they classify the data. This is the starting point of this particular class, and so this is called as hyperplane. Now the next one is support vectors. So support vectors means data points that are closest to hyperplane. So this called as support vectors. See here, in this blue class there is a blue dot is there, right? And in this green class there is a green dot is there, and these data points are closest to hyperplane, means from this point hyperplane is generated, right? So these 2 points are called as support vectors. And now the next one is margin. So margin means the particular gap between the two lines or close data points of different classes. So this is a decision boundary, and this is called as margin. See, this margin is properly classify the data or accurately classify the data in two class. So this is a perpendicular distance from line to the support vectors, right? And suppose your large margin, okay, the large margin is considered as a good margin because they perpendicularly classify the data. And if there is a small margin, this considered as a bad margin. Means if there is a lot of distance between the two classes, it means data can be properly classified. Large margin is a good margin, right? So middle line is called as maximum margin hyperplane, and this is a particular distance that can be denoted by the maximum margin. Okay. So these are the components of support vector machine. So what we learn? First one is a hyperplane. Hyperplane means decision plane. Next, support vector. Support vector means data point that are closest to hyperplane. From this particular point, hyperplane is generated. And margin means decision boundary. Margin, they can classify the data in two classes properly and proper distance. Large margin is considered as good margin and small margin is considered as bad margin. So these are the components of support vector machine. Now next, there are two types of SVM. One is linear SVM classifier, another one is non-linear SVM classifier. See here in this first diagram, this is linear SVM classifier, means two classes are properly classified by using single straight line. So this is called as linear SVM classifier. And next one is non-linear SVM. Non-linear SVM generally used in non-linearly separable data. In this data set, we can't classify the data into the particular straight line, right? We can't classify the data by using straight line here. So this is called non-linear SVM classifier. So in this non-linear SVM classifier, kernel is used for classifying the data. I will explain in this next session, next slide. Okay. Now these are the some SVM algorithm steps. How SVM algorithms are work. So first step is you need to select two hyperplanes, right? Hyperplanes is a first step. Second step, you need to maximize their distance. The distance between two hyperplane is maximum because they accurately classify the data. And third one is the average line, or we can say the decision boundary. This is your third line, right? So these three steps are included in SVM algorithm. So let's see. Okay. Now the next point is working of support vector machine. How exactly support vector machine will be work. So the first scenario is data is linearly separable. See here in this particular diagram, the data is linearly separable, means there is a linear data. So there are two classes, one is apple class and another one is lemon class, right? But in SVM support vector machine search a particular apple that are very similar to lemon, or lemon that are very similar to apple in this way. So this is the concept, means they can classify the data as per their particular features. So in this diagram, see here, the in apple, this apple is sometimes or somewhat similar to lemon, and in this way this lemon is somewhat similar to apple. So these are the support vectors. Okay. So the other support vectors, lemon similar to an apple. For example, we can provide the features like green and rounded. So these things are called as lemon, right? But sometimes somewhat some apples are in this rounded shape, or some apples are also green, right? So this algorithm, SVM algorithm, learn the similarity, and as per their similarity they classify the data. So this is a concept of support vector machine. Right. Now next, see here in this data set, support vector machine, they classify the data. They generate a best hyperplane to separate the classes, okay, and find out the decision boundary. So by using, when you apply the support vector machine algorithm, at that time this kind of decision boundary is generated. So this is a maximum margin. See, from these support vectors there is a proper distance between these support vectors, right? So this decision boundary is called as support vector machine, means they generate or accurately classify the data. So support vector machine find the two closest support vectors and separate the classes with optimal hyperplane, right? Means as per the support vectors they classify the particular classes, and this is the decision boundary. Now what is meant by optimal hyperplane? Okay, this is the next concept. See here, suppose in this first diagram, see here, there are multiple hyperplanes are there. These blue lines are called as hyperplanes, right? But which is the best hyperplane, or which is the best line to the line which properly classify the data or classify the classes? So support vector machine identify the optimal hyperplane or best decision boundary to classify the data. This is also work of support vector machine. See here in this second diagram, the middle line, that is blue color line, they properly classify the data, right? And this red line indicate the hyperplane. Hyperplane means hyperplane that is nearest to data points. See here, these are the two data points, that is one is here, this is the two fruits are there, one look like apple and another look like lemon. So these are the two data points. These data points are called as support vectors, and this data points is nearest to hyperplane, and these are the hyperplane. Okay, mean this is the starting point of this particular class and this is the starting point of this lemon class, and in between that there is a decision boundary, means they classify the properly data as per their features of lemon and features of apples, right? Next, now the next scenario is if your data is non-linearly separable. See in this particular diagram, data is non-linearly separable, means you can't mention the particular straight line in this particular data set. If you draw the straight line, data is not classified properly, right? So that's why in a non-linear separable scenario, kernel trick is used. So first we understand what is kernels. Okay, see. Okay, so basically kernel means they convert your low dimensional data space into the high dimensional data space. For example, they convert one dimensional data into the two dimensional format and two dimensional data into the three dimensional format in this way. So kernel is generally used a set of mathematical function that used support vector machine to provide the window to manipulate the data. Okay. So kernel, these mathematical functions are used in non-linear separable data and they classify the data according the particular features. Actually, there are various popular kernels are there, means polynomial kernel, Gaussian kernel, radial basis function, Laplace RBF kernel, sigmoid kernel, and Ano RBF kernel. So this kernel having their own functionality and own features. Means some kernels are used for image classification, some kernels are used for text classification, some kernels are used in deep learning. So as per the requirements, these kernels are used. Okay. So let's see the one example. Okay. Now see here, by using kernel, you need to classify the data. Okay. For example, see here, the first image is a one dimensional data. Okay. Suppose you draw the decision line in between the particular data set. So data is not properly classified, right? So at that time, this one dimensional data convert into the two dimensional format by using kernel. This is a work of kernel. Okay. Now see here in the second diagram, this is a two dimensional format of the first image. So when this particular diagram converted into the two dimensional format, at that time this middle line is called as decision boundary, right? And they classify the data. So kernel having particular mathematical function and they apply this mathematical function on this particular data set and they classify the data into the two classes. See here. So in this way they convert one dimensional data set and two dimensional format and they classify the data according the features. Now next one, see here. Suppose your dataset given into the two-dimensional format. See here in this first image, your dataset is a two-dimensional format. Okay, you can't draw a particular straight line in between this dataset because they can't classify the data. So at that time, you need to convert this two-dimensional dataset into the three-dimensional format. Okay, so the basic idea is data set is inseparable in the current dimension. Okay, so at that time, you need to add some another dimension. So this is a work of kernel. Okay. So when kernel convert this two-dimensional dataset into the three-dimensional format, so at that time this data is represented in this format. This is the second image, right? So see here, they convert the data into the three-dimensional format, and this middle line is called as decision boundary or hyperplane, right? They classify the data as per their features. So this is a work of kernel. Now the next concept is support vector machine is soft margin. So what exactly soft margin is? So soft margin find outs or tolerates a few dots to get misclassified. So what is meant by misclassified data? Now see here in this diagram. There are two types of misclassification. Okay. The first misclassification is dot is on wrong side of the decision boundary but on correct side of margin. See in this diagram. For example, see here in this red dot. So this red dot is on the decision boundary, right? There is a one red dot, this red dot on the decision boundary, right? And but this data is on correct side but on decision boundary. So this dot is called as misclassification. Okay. Now next red dot, see here. There is a one red dot. This red dot in a blue class, right? And also is on other side of decision boundary. Means this data is also misclassified, right? So there are two types of misclassifications are there. Wrong side of decision boundary and correct side of margin, and another one is wrong side of decision boundary and wrong side of margin. So this thing is called as soft margin SVM. So soft margin as SVM balance the trade-off between the maximize the margin and minimize the misclassification. So this is the concept of soft margin. So there are some advantages and disadvantages of support vector machine classifier. So advantages are support vector machine classifier offers a great accuracy, right? And they properly work in high dimensional data space. And next one is a support vector machine is basically use of subset of training points, and result use very less memory. And disadvantages of support vector machine, they have a high training time, right? Because in they convert a one dimensional two dimensional, means there is a high training time is required, so it is not suitable for the large data set. And they also not work well in overlapping classes. They required a proper supervised data for classification. So these are the some pros and cons of SVM. So thank you. Hope so everyone understood the concept of SVM. Keep practicing and please subscribe the channel. Thank you.